Hello everyone, my name is Colin Grant, and today we're going to be talking about truncated square tangles. So when thinking of squares and octagons, when put together, they make a truncated square tiling, which looks like this. So each octagon has four squares on each side, one to the north, one to the south, one to the east, and one to the west. And it also has four octagons in each diagonal direction. And you can also just look at one single square. I know it's kind of hard. It kind of makes you look like you're in a 3D picture. But if you can picture the one square, it has four octagons touching each side of it as well. So here we have each square has a quarter link that can be cut through it, and each octagon has a 3/8 link of a circle that can be cut through them, as shown in the picture here. Truncated square tangles are when you combine two links together. So like in the previous picture, when you take those two links and let's say from the square you had when it was covering that one corner, then you just take your 3/8 link and you connect it there. And when you keep doing that around the truncated square tilings, you will make a closed curve. If m and n is the length of a given truncated square tangle, with m equaling number of quarter links and n equaling number of 3/8 links, then what can you say about m and n? So here in the picture, I have the simplest case of the truncated square tangles. So here we have a 1/4 link in our square, and then we have two 3/8 links in our octagons, which makes a circle. So then we have m equals 1 and n equals 2. M being our links in our square, and n being our links in our octagon. With this next case, it's just one octagon and one square. Excuse me. So how we draw these is, if we're looking at the octagon, we're going to start on one corner, we're going to make a solid black dot. Then on the next one, we're going to make an open circle. And we're going to keep repeating that same process all the way back to where we can't make a dot anymore, or we're back to the beginning. So each black dot is going to be inside our closed curve. And each open circle is going to be outside of our closed curve. So here, as you can tell, I started on the left-hand corner, I went around, and to me it kind of looks like a ninja star. And with that one, our m equals 4, which we have 4 links in each square, as you can tell, and our n equals 8, which we have 8 links in each octagon. Our next one is just the square, as we have a black dot and a black dot on each diagonal, and we also have 2 open circles on each of the other 2 diagonals. So this one to me kind of looks like a peanut. This one we have m equals 2 and n equals 4. So here we add shapes. Here we're adding an octagon and a square. These are the only two patterns you can do when you're only having 2 shapes. You can either have an octagon or a square octagon. So here in the first picture, we have 2 octagons. Our m equals 7, so we have 7 quarter links in the squares you see in the picture, and then we have our n, which equals 14, which that is our 3/8 links in our octagons. Here in our second picture, we have an octagon square. As you can see in this is our first closed curve, but you can tell that there's 3 more squares around the octagon. Yes, you can pick any 4 squares, but in this case you can pick any 3 squares you want, and it's still going to make the same looking closed curve, just pointed in a different direction. So here our m we have equals 5 and our n equals 10. As I'm sure you can already tell, our m and n seem like they have a pattern going on. Just pay close attention to that as I proceed through this lecture. So here we're going to add 3 shapes. There are 5 different ways that this can be drawn. So this first one, we have an octagon, octagon. I made a small little V with this, but you can also draw them in 3 consecutive, just like in a diagonal, as in the square tilings, as you can see there. But with this one, our M equals 10 and our N equals 20. Moving on to our next picture here, I have an octagon, square octagon. I drew it straight down. You can also draw it vertically. It'll be the same picture. But here we have M equals 8 and our N, which equals 16. So here we have 8 quarter lengths in each square, and we have 16 3/8 lengths in our octagons. Here in our next one, just like I showed or was telling y'all in the previous one, these are the ones to me that you can really see the different ways that you can draw them, because it's just an octagon and you have 4 squares to pick from. So here I picked the top one and the right one. You can also pick the bottom and left, or you could pick the top and the left. It doesn't matter. It's still going to make the same closed curve. So with this one, we have M equals 6 and our N, which equals 12. So this next one is a square, octagon, octagon. And as like in the previous picture, you can pick, as long as you have 2 octagons that are touching, you can pick any of the surrounding 6 squares around it, and to draw this. And this one is M equals 8 and our N equals 16. So this is the last case I performed in my capstone. This has 4 different shapes. So you can, any 4 different configurations that you can come up with: an octagon, 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 square, square, octagon, square, 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 octagon. Either way, any of those different shapes that you can think of. And there are 12 different closed curves that you can make with 4 shapes. I picked 3 here. These are the 3 that stood out the most to me, that I don't know, that were just interesting to me, I guess you can say. And so this first one is an octagon, octagon, octagon. You can draw this one in a couple different ways. You can have 3 coming down and 1 to the left or 1 to the right. I just drew them straight down. So in here, this one, we have M equals 13 and our N equals 26. So as to be expected, the more shapes we have, you think, oh, our numbers are going to start growing. Yes, they do. But not so much with this next case. This case is why I picked it, because it stands out to me a lot, I guess you can say. This one, we have an octagon and 3 squares. So this one is our M equals 7 and our N equals 14, which I know you're probably thinking to yourself, oh, you just said 4 shapes, then our numbers are going to be bigger. Yes, that is so with our first picture, because our picture is so spread out and takes up so much more area. With this one, it's closed and compact. It's all right there together. And that's why I picked this one, because it's, I guess you can say, out of the ordinary of the other shapes that you can draw with 4 shapes. And this next one is octagon, octagon, octagon square. This one has M equals 11 and N equals 22. So as I've said before, we have 11 quarter lengths in each square, and we have 22 3/8 lengths in each octagon. So here's just a table, I guess, so you can see it visually, of what I've been talking about, how many lengths, quarter-inch lengths are in each square, and how many 3/8 lengths are in each octagon. So in our first shape, we have, oh, excuse me again, we have 1 quarter length, and then 2 3/8 lengths, 4 quarter lengths, and then 8 3/8 lengths. And then with 2 shapes, we have 5 quarter lengths, 10 3/8 lengths, 7 quarter lengths, and 14 3/8 lengths. And with this being said, our M equals 2N. So for how much ever the value is for M, we are always going to have double that for our N, which is our octagons. So you can say 2N, yes, that is half. So whatever our N equals, we're going to have half of that in each square. Thank you for taking your time to listen to me today. I hope y'all have a great day.